Hello friends, I am Aryan Garud, working as Assistant Professor in Children's Institute of Technology, College of Engineering. So in this lecture we are going to study what are the parameter adjustment and the concept of omitted measurement. So in this slide we are going to see the parameter adjustment, what are the objectives and which are the fundamental lines which we consider for the parameter adjustment. So a theodolite consists of several fundamental lines. In order the reading to be accurate, certain desired relationship must exist between the fundamental lines of the instrument. But due to improper handling or excessive use, this relationship may be disturbed and hence the reading from the theodolite may lead to erroneous results. So for rectifying a disturbed relationship, some procedures termed as parameter adjustment are adopted. The fundamental lines of the theodolite are given below. First is vertical axis. Second is the axis of plate level, that is plate bubble. Third is line of collimation. Fourth is horizontal axis or trunnion axis. And fifth is bubble line of altitude bubble. So these are the 5 fundamental lines, and we are trying to see the desired relationship between these fundamental lines. The desired relationship between the fundamental lines are given below. First is the axis of plate level must be perpendicular to the vertical axis. Second is the line of collimation should coincide with the optical axis of the telescope and should also be perpendicular to the vertical axis. Third, the horizontal axis must be perpendicular to the vertical axis. The axis of telescope must be parallel to the line of collimation. The line of collimation must be perpendicular to the horizontal axis, and the vertical axis should read 0 when the line of collimation is horizontal. So these are the 5 fundamental lines, and for that we are trying to check whether the given instrument has got a desired relationship or not, and depending upon the observation we are going to say that whether the given instrument can be used or not. So the first adjustment regarding the parameter adjustment is to make the axis of plate level perpendicular to the vertical axis. Therefore, in order to check this particular adjustment, we have to follow the procedure given below. Initially, the theodolite is set up on firm ground with its leg well apart and firmly fixed on the ground. Second, the plate bubble is made parallel to any pair of foot screws and brought to the center of its run by turning the concerned foot screws. Third, the bubble is turned through 90 degrees and then brought to the center by turning the third foot screw. Fourth, the process is repeated several times until the bubble is perfectly centered in these 2 positions. Fifth, the bubble is turned through 180 degrees about the vertical axis. Sixth, if the bubble still remains in the central position, the axis of bubble is perpendicular to the vertical axis, which may then be assumed to be truly vertical. Seventh, if the bubble does not remain in the central position after step number 5, the amount of deviation is noted, say it is 2n divisions. Then the adjustments are done as given below. First adjustment, hold the total deviation, that is n divisions, and is adjusted by means of capstan headed nut provided just below the bubble tube. Then the remaining half of n division is adjusted by turning the concerned foot screw. The process is repeated several times until the bubble remains in the central position for any direction of bubble tube. Then the second adjustment, to make the line of collimation coincide with the optical axis of the telescope. First, the horizontal hair and then the vertical hair are adjusted. So the adjustment of horizontal hair is carried out as per the figure 9.31, wherein the T is the position of instrument, capital A and capital B, these are the position of staff, and capital small a and small b, these are the 2 hair readings, central hair reading at A and B, and B1 and B2, these are the other stadia hairs. Then 3 pegs are given into the ground at T, A and B, a known distance apart. Then the theodolite is set up at T, and after proper adjustment, staff readings are taken on A and B. Suppose the readings are AA and B, B1. By transiting the theodolite, the star readings are taken on A and B. If the readings of the second observation tallies with those of the first horizontal hair, then the horizontal hair is in adjustment. If the second observation gives a new reading, say BB2, then the horizontal hair requires adjustment. The adjustments are done as given below. The mean of two star readings obtained from two observations is calculated. Let it be BB. By turning the vertical diaphragm screw, the horizontal hair is brought to the reading BB. The process is repeated for several times until the horizontal hair is perfect in all conditions. Then we are going to see how the adjustment of vertical hair is to be done. In this adjustment, we are going to make the line of collimation perpendicular to the horizontal axis. The following procedure is adopted prior to making necessary adjustment. The theodolite is set up at T. After proper leveling, a ranging rod is fixed at A by looking through the telescope, keeping the upper and lower clamps fixed. By transiting the telescope, a ranging rod is fixed at B. The upper clamp is loosened, and by turning the vernier plate, the ranging rod at A is again bisected. If the ranging rod at B is seen bisected after transiting the telescope, the vertical hair is perfect. If not, the amount of hair or error is noted. Let BB1 be the total error. Then the adjustment is done as given below. A position is marked by ranging rod at B dash, where B1 dash B dash is 1/4 the total error, as shown in the figure 9.32. So in this slide we are going to see how to make use of the consecutive coordinates for finding the required area of a closed traverse. So let us consider the problem wherein the sides latitude and departure are given. The sides are AB, BC, CD and DA, and the values of latitude and departure are given as given below. The conjugative coordinates are arranged in independent form as given below. So whenever we are going to prepare the independent coordinates in the form of latitude and departure, so we are going to consider the stations. So station is A, station is B, C, D and A. Since it is a closed traverse, it is going to close at A. So starting with B, the side is AB. So we are going to consider the conjugative coordinates in front of AB. So they are 225.5 and 120.5. And accordingly at C we are going to write the side BC, and we are going to take the latitude and departure value, that is values of conjugative coordinates, in the respective column. Similarly for CD and similarly for DA. After that, by considering the maximum negative value out of latitude and departure, we are supposed to consider we are supposed to assume the coordinate of starting station A, and they are considered as plus 200 and plus 100. Plus 200 is latitude and plus 100 is departure. So here northing and easting values are considered. So starting with 200, in order to calculate the independent coordinate for the line AB, we are going to consider what is the latitude value of AB line. So latitude of A plus latitude of AB gives you the independent coordinate of line AB, that is 425.5. 200 plus 225.5 gives you 425.5. Similarly, by making use of 425.5, we may consider the next line, that is having the latitude minus 245. Since it is negative value, we have to subtract from the latitude of AB. So 425 minus 245 gives you 180.5. Then by considering 180.5 as a independent coordinate for line BC, we will consider the conjugative coordinate of line CD, and it is minus 150. So it has to be subtracted. So 180.50 minus 150.50, it is 30. So 30 is the independent coordinate for line CD. Similarly, we can calculate, or we may consider the latitude of line D, that is 170 plus 170. So 30 plus 170 is 200. Similarly, we can calculate the coordinates or independent coordinates for departure also. So 100 is the assumed coordinate of A. So 100 plus departure of AB line is plus 120.5. So 100 plus 120.5, it is 220.5. Similarly, by considering 220.5 and considering the next departure, that is plus 210, we are going to add 220 plus 210, it is 430.5. So 430.5 is the easting value of line BC. Then we will consider the departure of CD, that is minus 110.5. So 430 minus 110.5 gives you 320. So again from 320 we have to subtract, since the departure of DA is minus. So it gives you the departure of A as 100. So 200 and 100, these are the values which are assumed in the initial or in the beginning. So whatever the calculations we have done, they are correct. Then the independent coordinates of all stations become positive. Therefore they are lying in the first quadrant. So the coordinates are arranged in the determined form as given below. That is 200, 100. First of all, you have to enter in along the row the latitude values or the independent coordinate of A, B, B, C, C, D, A point, B point, C point, D point, and A point. Similarly, by arranging the departure values of stations A, B, C, D, A in the next row, that is 100, 220.5, 430.5, 320 and 100. Then we have to draw the continuous line and dotted lines as shown in the diagram. Then we have to do the calculation, that is sum of product of coordinate joined by solid lines. So continuous line or solid line, we have to make addition. So summation P equal to sum of all product of coordinates joined by solid lines. That is 200 multiplied by 220.5 is one of the product. Similarly 425.5 multiplied by 430.5 is another product. Similarly 180.5 multiplied by 320 is another product. Similarly 313 multiplied by 100 is another product. So the total is summation P. Similarly, in the similar fashion, we can calculate the sum of coordinate for dotted lines, and that is stated as summation Q. And then by making summation P and summation Q, we can calculate the required area, that is summation P minus summation Q divided by 2. So we may get the required area, that is 64,386.25 meters square. So this way we can calculate the area of any traverse by making use of conjugative coordinates. Then in this slide we are going to see how to solve the problem on omitted measurement. So generally in the omitted measurement, generally the field observation such as length or bearing of a line, they are missing, and when these are missing, how to calculate the other parameters which are required for calculating or plotting the given traverse. So in the given problem, the line AB, BC, CD and DA, that is station consisting of 4 points are given, and the length and bearings are given. So for the first line AB, 100 meters is the length, but bearing is missing, it is not taken. So therefore we are going to consider this as a omitted measurement. Similarly for line BC, length and bearing are given. Similarly for line CD, length and bearings are given. But for DA, length is not known but bearing is known. So the missing measurement is length as well as bearing of line AB. So here in this particular problem, we have to calculate the bearing of line AB. At the same time, we are supposed to calculate length of line DA. So for that, we are going to consider L as length of DA and theta is the bearing of AB. So the calculations of latitude and departure of traverse are arranged in a tabular form as given below. So we are going to arrange the latitude and departure. So line, length, whole circle bearing, reduced bearing, latitude and departure. First of all, since the given bearing is is in the WCB, we have to convert the WCB into reduced bearing. So reduced bearing is given in the table of reduced bearing column. So 140.30 is the WCB of BC. So we have to from that, in order to calculate the reduced bearing of BC, we have to subtract the given bearing from 180 to get the reduced bearing of line BC. So 180 minus 140 degree 30 minutes, that is 39 degree 30 minutes. That is southeast quadrant. That is that particular line in the second quadrant. That is southeast quadrant. So we are going to attach southeast. Similarly, the line CD, it has got WCB of 220 degree 30 minutes. It is lying in the third quadrant. Since it is lying in the third quadrant, we have to subtract 180 from the given bearing. So 220 degree 30 minutes minus 180 degree. So that is 40 degree 30 minutes. Similarly, the line DA. So line DA has a bearing of 310. Since that particular line lies in the fourth quadrant, we have to subtract from 360 degree the given bearing. So 360 minus 310, that is 49 degree 45 minutes. And the concerned quadrant is northwest. So we can make use of this. So since the line AB has missing bearing, so we are going to consider theta as reduced bearing of line AB. So we can calculate latitude and departure as 100 cos theta and 100 sin theta. Similarly for line BC. So BC has a length 80, whereas 39 degree 30 minutes is the theta value. So 80.5 into cos 39 degree 30 minutes. Since the latitude is measured towards south, it is considered minus. So minus 62.12. Similarly, the departure value of line BC, that is 80 into sine 39 degree 30 minutes. Since it is measured towards east, therefore it is positive. Therefore plus 51.2. Similarly for line CD, the length of line CD is 60 and the reduced bearing is 40 degree 30 minutes. Therefore 60 into cos 40 degree 30 minutes. And since in the third quadrant latitude and departure both are negative, so the negative value is given for latitude and departure. Similarly, if a line in the fourth quadrant for line DA, since L is given, L is the length of line and the 49 degree 45 minutes is the reduced bearing of line DA. So therefore L cos 49 degree 45 minutes is the latitude of line DA. Similarly, departure of DA is L sin 49 degree 45 minutes. Since that particular departure is measured towards west, it is considered negative, whereas the latitude of line DA is measured towards north, therefore it is positive. So in this slide we are going to see how to apply the check for algebraic sum of latitude and departure, and that must be equal to 0. So we are going to consider the latitude value for all the sides AB, BC, CD and DA. Since the length of line DA is not known, we are going to consider in the form of L. So this is the equation number 1. Similarly, we are going to add the algebraic sum of all the departure, that is 100 sin theta. Since theta value, that is reduced bearing of line AB, is not known, therefore it is 100 sin theta, and 51.2 is the departure of BC, 38.97 is the departure of CD, and 0.763 is the departure of DA. Since length of line DA is not known, so by getting the values of DA, that is two values 145.8 and 12.04, we are going to calculate the theta value, that is the value of reduced bearing for line AB. So considering equation number 1, substituting the value of L, we may get cos theta equal to 0.1355. Similarly, by considering equation number 2 and putting the value of L as 145.8, you can get the value of sin theta as plus 0.9901. Since both cos theta and sin theta, they are positive, the line AB lies in the first quadrant, that is northeast quadrant. Therefore, we can calculate tan theta equal to sin theta upon cos theta. Therefore, the value of tan theta is 7.307. Therefore, the bearing of line AB is equal to n 82 degree 12 minute east. Similarly, when we consider the second value of length of line DA, L equal to 12.04. So you can substitute the value of L equal to 12.04 in equation number 1. We get value of cos theta as 0.9996 positive value. Similarly, by substituting value of L in equation number 2, that is, we get the value of sin theta as minus 0.0304. It is minus value. Since cos theta is positive and sin theta is negative, the line AB lies in the northwest quadrant, that is in the fourth quarter. Therefore, tan theta equal to 0.0304 divided by 0.9906. So it comes to be 0.03. So the value of theta comes to be 1 degree minus 1 degree 44 minutes. So the bearing of line AB is n 1 degree 44 minute west. If the value of the length calculated by solving the quadratic equation turns out to be negative, the value should be ignored. Thank you friends. In this slide we have seen the parameter adjustment. At the same time, what is the concept of omitted measurement and how to solve the given problem by applying the check for closed hours. Thank you.